Hi, good day. Welcome in today's episode of DepEd TV. I am Sir Jason Flores, also your math buddy, and I will be here to help you in developing your logical reasoning and critical thinking skills. Is your self-learning module ready? What about your pen and paper? Great! Let's begin a fun and exciting lesson. For this lesson, you are expected to familiarize yourself with the formulas in finding terms of geometric sequence. Also, find the nth term of a geometric sequence and determine the geometric mean or geometric means of a geometric sequence. Episode, you learned about geometric sequences and how to find the next terms of geometric sequences. In this episode, we will discuss ways in finding the nth term of a geometric sequence. For example, what is the seventh term of the sequence 5, 10, 20, and so on? First, let's determine the common ratio. What do you think the common ratio is? That's correct. The common ratio of this sequence is 2. Thus, the next three terms are 40, 80, and 160. And you can easily identify the seventh term when you multiply 160 by 2. You will obtain the seventh term, which is 320. Now, what do you think is the 10th term? Using the geometric sequence 5, 10, 20, and so on, you are asked to find for the 10th term. Let us now use a formula which may help us find an unknown term of a geometric sequence. The formula in finding the nth term of a geometric sequence is a sub n is equal to a sub 1 times r raised to n minus 1. Again, the formula in finding the nth term of a geometric sequence is a sub n is equal to a sub 1 times r raised to n minus 1. Wherein a sub n is the nth term, a sub 1 is the first term, r is the common ratio, and n is the number of terms. Using the sequence 5, 10, 20, and so on, let's use the formula in finding the 10th term of the geometric sequence. The given a sub 1 or the first term is 5, the ratio which is equal to 2, n is 10. Again, we are looking for the 10th term. Now, let's substitute the values in the formula. Our a sub n will be a sub 10 equal to our a sub 1 is 5, our r is 2, raised to n, our n again is 10, so that's 10 minus 1. Next, we'll have a sub 10 is equal to 5 times 2, raised to 10 minus 1 will give us 9. Then you have a sub 10 is equal to 5 times 2 raised to 9. It means that you have to multiply 2 by itself 9 times will give us 512. A sub 10 now is the product of 5 and 512 will give us, that's right, 2,560. Thus, the 10th term of the geometric sequence is 2,560. Incredible! Now, let's have another activity. What is the seventh term of a geometric sequence whose fourth term is 128 and the common ratio is equal to 4? To begin with the problem, you must have to analyze carefully what does it ask for. The problem is asking for the seventh term, but the first term was not given. First, identify the given values and the unknown variables. For this problem, the given terms are a sub 4, or the fourth term, which is equal to 128, and the common ratio, which is equal to 4. There are two unknowns: the first term, or a sub 1, and the seventh term, or a sub 7. Now let's use the formula. A sub n is equal to a sub 1 times r raised to n minus 1. Again, there are two unknowns in the problem, and to solve for a sub 7, we need to solve first for a sub 1. Since the given term is the fourth term, which is equal to 128, we can use it to solve for the value of a sub 1. Now, let's substitute the value of a sub 4, which is equal to 128, n, which is 4, and r, which is also 4, in the formula. A sub n is equal to a sub 1 times r raised to n minus 1. We will have 128 is equal to a sub 1 times the ratio, which is 4. Our n is also 4 minus 1. Then we have 128 is equal to, let's copy first a sub 1 times 4, and 4 minus 1 will give us 3. Next, we will have 128 is equal to a sub 1 times 4, multiplying 4 by itself 3 times will give us 64. Then, divide both sides by 64 so we can isolate a sub 1. (64) divided by 64 will give us 1. What's left is a sub 1, and 128 divided by 64 will give us 2. Thus, the first term of the sequence is equal to 2. Since we have our first term, we can now solve for the unknown term, which is a sub 7. Again, using the formula, a sub n is equal to a sub 1 times r raised to n minus 1. That's a sub 7 is equal to a sub 1, which is 2, times r, which is 4, raised to 7 minus 1. Next, we will have a sub 7 is equal to 2 times 4 raised to 7 minus 1 will give us 6. A sub 7 is equal to 2 times, we will multiply 4 by itself 6 times, will give us 4,096. And finally, multiplying 2 to 4,096 will give us 8,192. Thus, the first term and the seventh term of the sequence is 2 and 8,192 respectively. Great job indeed! Now, it's more swift and convenient to find the nth term of a geometric sequence using the formula, right? Now, let's try to see what you have learned from today's episode by answering this question. Find the specified term of the geometric sequence given the first term and the common ratio. the problem tells us to solve for the fifth term. Before that, let's determine first the given values. We have a sub 1, which is equal to 3, and the common ratio, which is equal to 3. After that, let's use the formula in finding the nth term of a geometric sequence. A sub n is equal to a sub 1 times r raised to n minus 1. We have a sub 5 is equal to our a sub 1, or the first term is 3, times the common ratio, which is also 3. Our n is 5 minus 1. Then you will have a sub 5 is equal to 3 times 3 raised to 5 minus 1 is, correct, 4. A sub 5 is equal to 3, then multiply 3 by itself 4 times. That's 3 times 3 times 3 times 3 will give us, correct, 81. A sub 5 is equal to the product of 3 and 81 will give us 243. Thus, the fifth term of the sequence is equal to 243. Also awesome! Well, how was the experience so far? Wonderful! To further enhance your knowledge and skills about this topic, let us discover a shorter way to identify the unknown term or terms in between terms of geometric sequences, also known as geometric means. Let's take a look at this example. 12 blank 3. The given terms are first and last terms. These terms are called the extremes, and the term or terms in between the extremes are called geometric mean or geometric means. In the sequence 2, 4, 8, 16, the numbers 4 and 8 are the geometric means of the extremes 2 and 16. I know that you are very eager to explore more about this lesson. Well, let's begin. Let's go back to the problem. 12 blank 3. The first term is 12 and the last term is 3. Now, let us substitute. But remember, the common ratio refers to the ratio of two consecutive terms. With that, we will use a sub 3 divided by a sub 2 is equal to a sub 2 divided by a sub 1. Now, let's replace it with the given values. For a sub 3, or the third term, we have 3 over, or divided by the second term, which is a sub 2, is equal to, a sub 2 is still unknown, so we'll just write a sub 2 divided by the first term, a sub 1, which is 12. Next, let's do cross multiplication. For this part, we will multiply a sub 2 times a sub 2 equal to 12 times 3. A sub 2 times a sub 2 will give us a sub 2 squared. That's correct. And 12 times 3 will give us, correct, that's 36. Next, let's apply getting the square of each term. So we'll have the square root of this, a sub 2 squared. What's left will be a sub 2, and the square root of 36 is 6. Thus, the geometric mean or the second term of the geometric sequence is 6. Buckle up, fasten your seat belts as we move on to the next example. Come and join me as we solve this problem together. In the geometric sequence 2, blank, blank, 250, there are two geometric means needed in this problem. Let us identify first the extremes and the number of terms. The extremes are 2 and 250, and there are 4 terms in the sequence. So, to insert terms, let us identify first the common ratio by using the formula R is equal to n minus k and the square of a sub n all over a sub k, with the given a sub 1, which is equal to 2, a sub 4, which is equal to 250, our n, which is equal to 4, and k, which is equal to 1. Now, let's substitute the given values to the formula. We will have R is equal to, our n again is 4, minus 1, and the square of our a sub 4 divided by our a sub 1. Now, use the values. We have R is equal to 4 minus 1. Our a sub 4 again is equal to 250 over a sub 1, which is 2. Then we will have R is equal to 4 minus 1 will give us 3, and the square of 250 divided by 2. Next, we will have R is equal to the cube root of 250 divided by 2 will give us 125. Getting the cube root of 125, that is equal to 5. Correct. Now, the common ratio of this geometric sequence is equal to 5. To get the succeeding term, remember to multiply the preceding term times the common ratio. Since we have 2 as our first term, we will multiply it by the common ratio, which is 5. So 2 times 5 will give us 10. And to get the third term, we will also multiply the second term by the common ratio, which is 5. So 10 times 5 will give us 50. Therefore, the sequence is 2, 10, 50, and 250. Congratulations! That was very nice. Thanks for helping me out. I hope you already developed the knowledge and skills you need in finding geometric means. Keep it up! To keep the fire burning, join me once more as we solve the following problems together. For letter A, find the geometric mean of the given extremes 3, blank, and 8. Again, we are looking for the geometric mean of the extremes 3 and 8. With that, let's use a sub 3 divided by a sub 2 is equal to a sub 2 divided by a sub 1. Let's substitute the values. Our a sub 3, or the third term, is 8 divided by the second term, is still unknown, so we will just copy a sub 2, is equal to a sub 2 again, is unknown, just copy, divided by our a sub 1, or the first term, which is equal to 3. Now, let's cross multiply these terms. You have a sub 2 times a sub 2 is equal to 3 times 8. All right. Multiplying a sub 2 times a sub 2 will give us, okay, that's correct, a sub 2 squared. And 3 times 8 will give us, all right, that's 24. Next, let's get the square of both sides. What's left here is a sub 2. Notice that 24 is not a perfect square, so we will look for two factors of 24, which is 4 times 6. Then we will have a sub 2. Since 4 is a perfect square, the square root of 4 is correct. That's 2 square root of 6. So the geometric mean of the sequence is 2 square root of 6. Now, let's proceed to letter B. Insert geometric means in the geometric sequence 2 blank blank 686. Again, we are looking for two unknowns, which are a sub 2 and a sub 3. With that, we will use the formula first in getting the ratio, which is square root of a sub n divided by a sub k and n minus k. Let's substitute the given values. So r is equal to, our n again is 4 minus 1, and the square root of a sub n, we will use the value a sub 4, and our a sub k is a sub 1. Next, we will have r is equal to 4 minus 1, and the square of a sub 4, our fourth term is 686, divided by our a sub 1, or the first term, which is 2. Moving on, we have r is equal to 4 minus 1 is 3. And 686 divided by 2 will give us 343. Getting the cube root of 343 will give us, correct, that's 7. Since we already have our common ratio, we can now solve and find the missing terms. Again, that is a sub 2 and a sub 3. To get a sub 2, we will multiply the first term by the common ratio 7. So that's 2 times 7 will give us 14. Correct. And to get the third term, we will multiply the second term, 14, times the ratio, which is 7. So 14 times 7 will give us 98. So the geometric means of this sequence are 14 and 98. To sum it up, in today's episode, you were able to familiarize yourself with the formula in finding terms of a geometric sequence. Also, you were able to find the nth term of a geometric sequence and determine the geometric mean or means of a geometric sequence. Awesome! I hope you learned a lot. Never give up, and remember, winners never quit and quitters never win. Keep loving math. And that concludes our lesson for today. See you again on the next episode. And please don't forget to like, share, and subscribe to the DepEd TV official YouTube channel. And this has been Sir Jason Flores also. Bear in mind that learning math will always be fun and easy. Be also, be awesome. Only here on DepEd TV.